All right, y'all. This is Superman here to help you guys get ready for your pre-cal test. So let's get started. All right, so we're going to be looking here at 10 to the 24 raised to the 3x equals 64 raised to the x plus 4. And there's a lot of different ways to approach this. What you're going to have to do is you're going to have to try to get 10, 24, and 64 to have the same base. So there's a number of ways of doing this. Um, in the key, they're using 4. They show that 4 to the 5th is 1024, and 64 is 4 to the 3rd. So that's how they're approaching it. Uh, if you've played the game 2048, you may know what 10 to the 24 is in terms of 2. That's actually what I would have done. I would have broke it all the way down to 2, and I would have seen that. I would have known that that's 2 to the 10th, and then 64 is 2 to the 6. Okay. So if you see that, if you're not certain, you see that it's even, you may just want to keep multiplying by 2 to see if it works. 4 is a little nicer because the numbers are a little nicer. You can see that the transition here from 2 to the 10th to 4 to the 5th is really just saying 2 squared raised to the 5th, right? So 2 squared is 4, 4, and that would give me 4 to the 5th. And here it's the same argument. It's 2 squared raised to the 3rd is 4. It's going to give me 4 to the 3rd. Okay. All right. So now that we have that, now we have it set up, now we can attack it. So I'm actually going to just rewrite the whole thing. I feel like it's too cluttered there. So we have 4 to the 5th raised to the 3x equals 4 to the 3rd raised to the x plus 3. X plus 4. So I'm using this version as opposed to the version with 2 just because the numbers are smaller, so it's a little easier to work with. And so what's going to happen here is when we raise something to another power, this means multiplication. So this is 4 to the 5th times 3x equals 4 to the 3rd times x plus 4. Now, if the bases match, then the exponents match. So this is going to be 5 to the 3x equals 3 times x plus 4. And so when we clean this up, this is 15x distribute here, 3x plus 12, and then we combine like values. So we subtract 3x, this is 12x equals 12, and so when we solve, it comes out actually, I love how these problems start out like super ugly and they come out super nice. X is 1, all right? And that's it, that's all you have to do for this one, okay? So get the bases to match up, get the exponents to match up, and then you win. All right. Super. Let's do the next one. All right. So our next one that we're doing, it's going to look a little uglier. So we have 6 raised to the 2x squared plus 16 equals 1 over 216. So obviously a tell is if you have a number like 6, which is pretty small already, and then you have a number like 216, you know you can break it down. Just as a little nice little tidbit to realize is that when you multiply by 6, 6 times 6, any number of times, the digit in the ones place or the unit place, it has to be a 6 because every time you multiply, you're always doing 6 times 6. So if you're not certain playing with the power of, like, you see 6 in the ones place, then you're like, let me try 6, just keep multiplying by 6 until I get to see if I get to one of those numbers. So 216, what I'm showing here is you got 1, 2, 3. 216 is 6 to the 3rd. But it's 1 over 216, which means it's a negative, okay, or the reciprocal. So we have 2, the 2x squared plus 16 equals 6 to the negative 3 raised to the negative 6x plus 4. What's really important here is to recall that these are quantities. So on the back side, right here, the power rule says that we multiply, so this becomes 6 to the negative 3 times negative 6x plus 4 equals 6 to the 2x squared plus 16. When these match up, then the exponents match up. And this is going to give me 2x squared plus 16 equals negative 3, negative 6x plus 4. Okay, so big deal here is this is a quantity. And from here, we're just going to clean it up. So that means we're going to distribute. I love when I hit magenta, it doesn't let me do it in magenta. Okay. All right. So this gives me 2x squared plus 16 equals 18x minus 12. And then I'm going to put all the x's, all the values on one side. So here's the big thing here. Every time that you see 3 different terms, that is a clue. Oops. That is a clue. X squared. That's a clue that you want to move everything over to one side and set it equal to 0. So if you have a, in other words, if you have a trinomial, you want to move everything over to one side. Okay. The other thing you want to do is when you see something like this is you can see that each of these are divisible by 2. So we're going to just do that. We're going to divide through by 2. So this is going to be x squared minus 9x plus 14 equals 0. And then we're going to finish it off. So we ask ourselves what times what is 14? That's 2 and 7. So x equals 2, x equals 7. And those are my 2 solutions. So they're going to put the solution as x is equal to 7, 2. This is why also it's real important that you practice these problems on your own so you're cool with the format. Also, one last thing. I should have mentioned this earlier with x equals 1 in the first one. You can always plug these values back in to check to see that it works. So I could have taken 7 and 2 if I'm not certain that it works and substituted back in. I'm using my Superman brain here to know that 7 and 2 work because, well, I'm looking at the answers as I work through these. So that's how I know that it's okay. All right, so let's do the next one. All right, so I just gotta blow this up a little bit. Come on. I don't know why this is making me think of Superman 4, where he has like these superpowers. It's a really old movie. He's got like random superpowers, like he can just like make the earth heal. Like I'm like using my Superman powers to make this problem bigger. Where's my hand? There it is. Superman powers to make this problem bigger. Okay. All right. Let's look at this one. Brianna invested $990 in an account paying an interest rate of 9.75% compounded continuously. Penelope invested $909 in an account paying interest of 9.9 compounded monthly. After 16 years, how much more money would Brianna have in her account than Penelope? Okay, so we definitely learned that Brianna would have more than Penelope. How come? And the answer should be if you're compounding continuously, that means you're compounding every moment, right? And Penelope is compounding monthly, which means she's only compounding 12 times in a year, right? So Superman contacts are falling out. So what that means is when we're looking at this situation, we want to realize that we're dealing with 2 different types of formulas, and also Brianna has to be more than Penelope because the more you cut up something within a period, the more interest that is accrued. Okay, so definitely B is going to have more than P. So what do we do here? All right, well, this part here is actually part of the solution. I made a mistake there. But what we're going to do here is, first off, we need to know what the formulas are. So if we compound continuously, this is our formula, right? And if we compound monthly, this is our formula. And these are actually the same thing. It's just as this goes to infinity and this goes to infinity, all of this becomes E, right? And then NT is RT at the continuous rate. Okay, so we're going to substitute in the values. So P, the interest rate is 9 3/4%, which is this. So, and then we have 900, the principal is 990. So principal is 990. E R is 0.0975. And we're doing this for 16 years. So there's the first one. And when I type this in, this is going to give me 4711.233. And so this is kind of interesting. So they round to this is the 10th, 100th, 1000th place, because you want to have a little bit more than what you're desiring, right? You technically we'd round this to 23 cents at the end, but you give yourself a little extra just in case that's needed for some comparison basis. So this next one is the same thing. I guess I should be doing this a different color. I keep going to the same colors. Okay, let's go blue. So again, 990 is still the principal. The rate is going to be the same. Oh, my bad, the rate isn't the same. It's 9.5. So it's going to be 0.095. Now, n is going to become 12 because we're cutting it up into months. And this is going to be 12 times 16. Because we're doing, how many intervals are we doing? Well, if you're doing it 12 times every year and you're doing it for 16 years, that's 12 times 16. Okay. So the important thing here is to make sure you type it in. And then you need to make sure that when you practice this, that you are getting these values when you type it into the calculator. Okay. So when you're plugging this in just to make sure your answer is correct with whatever calculator type of app you're using or calculator you're actually using, you got to make sure that it really does it's matching up. Okay, the last bit is saying how much more does one make versus the other. So clearly we're going to subtract. So 4499.4923 minus 4711.233. And so when we solve this, we get 211.7407, which is roughly 212. I think they're asking you to round to the nearest dollar. So it's 212. Yeah, round to the nearest dollar. Okay, so basically all this is an exercise of is making sure you substitute into the appropriate formula. Make sure you understand what all the variables are. Once you plug in correctly, you're just going to subtract the two values. Keep them rounded out as much as possible when you're doing this so that you don't see a mistake. I will be looking at your answer choices, so if they're like 1 or 2 points off, you're not going to be missing the question at the end of the day. So don't stress over that, but you want to make sure you really do know what formula you need to use for what. Okay, next one. And my super strength again to make the problem bigger. I like when they do that. These superheroes just random powers. And then they have like justifications for it. It's really funny. Okay, so this next one, y equals ab to the x, and we want to know what's the exponential function if it goes to the point 0.04 and 3, 2,916. So with this, anytime you see questions like these, I don't care what class you're in. If I say x is this, y is this, you can always plug those into the equation. So we're saying x is 0, y is 4. Plug it in. So this is going to give me 4a. B to the 0 is 1. So this is a is 4. And now that I know a is 4, I can go to the other equation. And we have, we now have, this is our equation, right? Because we know a is 4. We have this. And x and y is here. So y is 2916 equals 4, 3 to the x. And then we're going to solve this. So this is really important when you're solving this. You actually have to start by dividing by 4 because you want to get 3 to the x by itself. So this gives me 3 to the x equals whatever 2916 divided by 4 is, which is 729. And so Superman makes silly mistake. That's funny. It's saying x is 3, right? I'm like, that looks weird. So I had originally switched them. I don't know why. There must be some kryptonite laying around here somewhere. How do we get rid of b cubed? We do the cubed root. So this can be, you can actually type this into the calculator just to show you real fast. We have a lot to do in this review, so that's why I'm zipping through. I'm not typing most of these into the calculator. But I do want to show you that if you want to do this, you can actually hit math, and it's one of the functions, the fourth one, that actually does it. If it's above 3, you actually can type the number in and then hit the fifth one. So again, it's just math. You hit the fifth one, and it'll do the root. I personally like to just do 729. This is the same thing as 729 to the 1/3 power, which I think is a little easier to type in the calculator. You just caret 1 to the 3rd. And in case this gives me 9, b is 9. So now I can write the complete function as y equals 4 times 9 to the x. Boom. There's my answer. So hopefully that makes sense. Let's keep going. We got a lot to do. All right. Here's the next one. Okay. All right, so element X is a radioactive isotope such that every 14 years its mass decreases by half. Given that the initial mass of a sample of element X is 80 grams, how much of the element would remain after 18 years to the nearest whole number? Okay, so what do we need to do here? Well, we know that it decreases every 14 years and it's decreasing by half. So it's half as much. So this tells me that the equation is y equals, we have some initial amount a, every half year it's decreasing. I'm sorry, every 14 years it's half as much. So this is going to be, the way they're writing this is t over h. What I almost instinctively want to do from the get-go is put 12 here. I'm sorry, not 12, 14. I put 14. There really must be kryptonite somewhere around here. 14, because it's every 14 years, right? And A is the initial amount, so they tell us in the beginning of the question, we have initial amount of 80 grams. So this is y equals 80, 1/2 t to the 14. Right, this is t. So they're saying, what else are they saying? They're saying how much of the mass will be remained after 18 years. So that's going to be t. So this is y equals 80, 1/2, 18 over 14. And there you have it. So it's just familiarizing yourself with the equations that you have to use. And so this gives you approximately, the answer to be approximately 33. It says round to the nearest whole. Okay, they're getting 32.813, but that rounds to about 33. Okay, so realizing what equation you're going to substitute in, substituting correctly, boom, not that bad. Let's do the next one. Okay, so element X is a radioisotope that for every 11 years its mass decreases by half, given the initial mass is 70. How long will it take to reach 14? Okay, so we're going to, again, it's y equals a 1/2 t to the h, okay? Um, and so, and again, this makes sense because it's half decreases by half, so it's half every interval. The initial color code, the initial is 70, 1/2. The entire time is going to be, well, that's what we're actually asked to solve for, so that's going to be t. Oh, there we go. We are doing this. This occurs every 11 years, right? And so here we want to know how much long does it take to get 14. So the interesting part here is that y now is going to be 14. And we just have to solve this equation. So how do we go about solving this equation? When you see this, I mean, really, we're following PEMDAS here. And so you actually want to divide through by 70 first. You want to leave the base and the exponents by itself. So we do 14 over 70, which is what? 2 over 10, which is 0.1 over 5, which is 0.2, equals 1/2 t to the 11. Okay, so this is where it gets really interesting because we have to get rid of the 1/2. So in order to do this, we have to use logs. Okay, so what they do is they use the log of they use log. Did you say log? So they use log base 10. Okay. What I like to do is I'm going to use log base 1/2. Okay. The reason why I like to use log base 1/2 is, and you can look at their example, and if you want to use log base 10, which is just log, you can. I like to use log 1/2 because when these match up, we know that when these match up, it's just the exponent. So it's t to the 11th equals log 1/2 0.2. Now log 1/2 0.2, that's just a number. You're just going to have to type that into the calculator to see what it's equal to. We'll talk about how to do that in a sec. I'm now going to multiply by 11. All right, 11 times log base 1/2 to the 0.2 is t. And so now all I got to do is solve this. So how do we do this? All right. I have to move myself. Ah! All right, so what you can do here is first clear. Okay. So I do believe it's under math. Let's see here. I gotta pull this thing closer to me. Math. Why? Oh, I'm under alpha. That's why. Okay. Math. Math. Exit. Math. There we go. So now you just listen. Now you have a video of Mr. Anderson saying, or sorry, Superman saying math all day. All right. So I'm going to use this. There's actually a log base function here. I think most of y'all have the calculator that does that. And you hit that, and then you can type it in. So I'm going to use this 0.5 because it's easier to type in. And then I'm going to do 0.2, enter. That's weird. That's weird. So let's think about this for a second. Is it possible to take a log of 1/2? So this would go like so. So this is saying 1/2 to the x equals 0.2. Is there some way of writing 0.5? And yeah, there should be. Interesting. Not sure why it's not working out here. It should be working out. Okay. You would solve that. That would give the answer. Apparently, there is some issue here. So I'm going to show you what they did. So that should work. I don't know why it's not working. This calculator is a little goofy. Let's do it their way. So going back to here, they just use log. They don't use log base 1/2. They use, let's rewrite it. It's going to be 0.2 equals 1/2 t to the 11th. They just take the log of both sides. So this is going to become log 0.2 equals log 1/2 t to the 11th. Okay. Now, the reason why I didn't want to use this is we didn't really talk about this rule, but we're going to just do it right now. When you raise something, you put it in front. So this becomes t to the 11th log 1/2 equals log 0.2. Okay. This is a little tidbit. These are all related to each other, right? So if you ever want to know what the rule is for logs, because logs are exponents, they're just one derivation below the other. So exponents become, you can use multiplication. There's other rules. We didn't talk about this yet, but like, for example, when you multiply logs, it's the same thing as addition, and divide, it's the same thing as subtraction. So they're always like one derivation below the other one. So in any case, I put this in front, and then all I need to do now is divide by log 1/2. I guess I'm just going to do it this way because my calculator is not being a friend. Okay, so we get something like this, and all of this is going to equal to, let's see here, what do they get equal to? 2.32 equals t to the 11th. We multiply by 11, and we get 25.5 is t. I think there's some kryptonite around here somewhere. Okay, and again, you can check your answer. You can plug that number back in and see if you get to 14, right? So you can definitely take 25.5, plug it back in, and see, get approximately 14 because of rounding errors. There'll be some discrepancy. Okay, so yes, you can do it this way with 1/2. It will actually work. However, apparently my calculator doesn't work. So what I did was I put it as, you got to know this rule. The exponent can go in front, and then we can just divide and then multiply both sides by 11 and get the answer. So I guess I'm going to have to do that for the future problems because my calculator has kryptonite in it. All right, I got to make another joke besides kryptonite jokes with Superman. All right, blow it up. All right, let's look at the next one. Isaac invested $1,800 in an account paying an interest rate of 4.7 compounded continuously. So because it says compounded continuously, I'm immediately going to write A equals P e to the RT, right? Continuous means E is forever. Assuming no deposit or withdrawal are made, how much money to the nearest dollar would be in the account after 15 years? Okay, so Isaac invested 1,800. 1,800 is the initial. So that's 1,800. E to the R, so this is the rate, which, oh, by the way, when you do, it's 4.7%. 4.7% is just 4.7 over 100, as we saw earlier. That's just a fancy way of saying move the decimal place over 2. So we get 0.047. to the t. So t is going to be how long? That's 15 years. All right, so then we solve this, and this will get you roughly 3,600. So plug and check. Really what we're trying to emphasize is, hey, when do you use continuous versus the other formula? Okay, sure, let's do another one. And really, they're all the same formula, right? I hope that's very clear at the end of the day. Okay. Scarlett is going to invest in an account paying at an interest rate of 4% compounded daily. Now, so because it's daily, we know we're going to use A equals P1 plus R to the N over NT. Oh, look, now we're using the other formula. Okay, so now let's do this. So what's the principal? So the principal, they are going to tell us the principal, how much would need to account for to reach? Oh, how much would Scarlett need to invest? They're actually asking us for the principal. Okay. So this is 1 plus R. What's the rate? 4%. So this is 0.04 compounded daily. So it's when they say, when they talk about the rates, it's implied that it's annually. That's something that is needed to be said. And we assume that we're not in a leap year, so 365. And then T is how the duration of time, which is 8 years. And this is going to give me 54,000. Okay, so we clean this up. All right, so you would type all of this into the calculator on the right here. All of this gets typed into the calculator, apparently like orange today. And this is going to give me 5,400. I keep saying 5,400, 54,000. Really is kryptonite here. This is going to be 1.3771. They wrote it out way more than that, but I'm just going to go there. And then you just divide, right? Divide. So divide by 1.3771 over 1.3771. And so then when you divide this, you end up getting roughly P to be 39,210. I want to make a point here. So when I type this in, this one I'm actually going to type in, cross my fingers, right, that this calculator doesn't mess up on me again. So 1 plus 0.04 divided by 365 caret 365 times 8. Okay. So this gave me this really big number, okay? Now, the reason why I wanted to do this, let me see if this calculator has it here. So over in this corner in yours, there should be a store function. I think if I hit this, I think this is what it is. So if I hit yours, it'll look a little different, but it's basically has this like an arrow function, and you hit X. And the cool thing about doing that is that every time you hit X, that is that value now. So if you had any apprehensions in rounding, you could just write a rounded version here, but in your calculator, you could store it. You don't have to store it as X. You could hit alpha and store it as any letter as you want. Okay. So if you ever have like really ugly numbers, that's a really cool function on the calculator. I'm so glad that this calculator actually did that. That's so nice of it to work properly. Okay. All right. Not better. Next one. All right. So Harper is going to invest 6,900 and leave it in an account for 12 years. Assuming the interest is compounded daily, which interest rate to the nearest 10% would be in order for Harper to end up with 1170? Okay, so more of the same. He's compounding it how often? He's compounding it daily, right? So we know we're going to use a p to the 1 plus r to the n raised to the nt, and we're going to substitute in values. So he's going to invest 6,900 at what rate? He's doing it 365 times, 365, and then we're doing this for 12 years. And this is going to give, and we want to get 11,700. So this is what we get to play with. All right, so the first thing I'm going to do here is I'm a big fan of getting rid of, trying to get that r by itself as much as possible. So I'm going to start by dividing by 6,900. And this is going to give me 1 plus r to the 365 raised to, I can just multiply that together. It's going to give me 4,380. And then 11,700 divided by 6,900 is 1.69565. Okay. And then from here, okay, so I want to get rid of that 4,380. So what I'm going to do is I'm going to raise all of this to the 1 over 4,380. Okay, that is the same thing as saying taking the 4,380 root. So this is going to give me, let's see here, what's this going to give me? This is going to give me a very nasty number. This is going to be 0.123120571. Okay, equals 1. Sorry, 1.0 equals 1 plus r to 365. Okay, so this is this number, and the reason why I wrote it as just point is that the next thing I'm doing is I'm going to subtract 1. So that means the 1 goes away, and we're left with 0.123120571 equals 1 plus r to the 365. And we get that. Okay. And then to finish this off, just multiply by 365. And this gets you 0.044, which is r, which means that r is roughly 4.4%. And that is how they want you to write this out. So again, very important that y'all work through the homework so you get, notice here, to the 10th, there's 10th of a percent. So got to work through this Delta math homework so you understand how they want you to write questions. Okay? All right, next one. Okay. So we got a quantity with an initial value of 200 grows continuously at a rate of 55% per day. What is the value of the quantity after 1 week to the nearest? Okay, so because it's saying continuous, we know the formula is going to be P e to the RT, right? Like y equals P e to the RT. They are telling us that the initial, so the principal is going to be 200, right? It grows at a rate of 55, so that's 0.55. And it's saying after 1 week. Now, this formula is in relationship to, it says per day here. So if it says 1 week, we don't put 1, we put 7. And you solve this. So we get, when you solve this, 9398.61. And that's our answer. All right, let's keep going. All right, here comes a really big one. All right. You know it's fun when the problem, the question, takes up half the page. There we go. All right. So after sitting out of a refrigerator for a while, a turkey at a room temperature of 69 degrees Fahrenheit is placed into an oven. The oven temperature is 300 degrees Fahrenheit. Newton's law of heating explains that the temperature of the turkey will increase proportionally to the difference between the temperature of the turkey and the temperature of the oven, as given by the formula below. Blah, blah, blah. Okay. The turkey reaches a temperature of 126 degrees Fahrenheit after 1.5 hours. Okay. Using the information, find the value of K. Using the resulting equation, determine the Fahrenheit temperature to the nearest degree after 5.5 hours. All right. So we need to figure out what goes with what. So T subscript A is the temperature surrounding the object. I believe they said that the oven is 300 degrees, so this would be this is 300. Okay. And then it says the initial temperature of the object. I think that they said a turkey at room temperature, I think that's the initial, is 69. The time in hours. Well, I do believe that they told us that the turkey reaches a temperature of 126. So after 1.5 hours. So this is going to be 1.5, and this is going to be 126. And K is the constant. Okay. All right. So we got all of this information. Now we're just going to plug it in. So if we got T equals TA plus T naught minus TA e to the negative KT. If we plug in, we get 126 equals 300 plus 69 minus 300. E. It's so much math, I gotta move super bad. To the negative K T 1.5. All right, so we got everything. I think we got everything in there, right? Yep. And now we just clean this up. Okay, I'm writing up, so that means apparently I'm happy. So this becomes, I guess what? I want to clean up this first. So I got 126 equals 300. Self-conscious of me writing up negative 231 e to the negative k 1.5. Okay. 69 minus 300 is negative 231. Next up, we're going to change our colors and subtract 300 from both sides. So subtract 300 from both sides. Okay. And this gives me negative 174 equals negative 231 e to the negative k 1.5. I want to get rid of that. So I'm going to, and when I say that, I mean the negative 231. So I'm going to divide by negative 231. So e to the negative k 1.5 equals, now negative 174 divided by negative 231 is going to give me 0.7532-ish. And here's where we got to kind of, this is where, again, this is why our last lesson was important. We have to know how to play with logs. So we have E. And so to get rid of E, we take the natural log, right? Now remember, natural log is just log base e, okay? So basically using that property, right? So natural log is log base e, and so again, what does a log really mean when these two match up? It's just the exponent. So we do this, and we get the natural log of 0.7532. This would be a great place where when you type this in to use the store function key is equal to negative k to the 1.5. You can decide how you want to divide this. So I'm going to divide by negative 1.5. I'm going to take the negative and the 1.5 together. You don't have to, but I'm going to. And when we solve this, k becomes 0.189, roughly. Okay. So now we have k. So my equation is t equals 300 minus 231 e to the negative 0.189 t. All right, so basically I took this same equation. This is t 300 plus, just go ahead and leave it like, actually it's more like this, right? But now we know what k is, okay? And this is t. And then they ask us, what is it at 5.5? So now what I'm going to do is rewrite the same thing and plug in 5.5. All right. So when I solve this, I got 218. Okay. And that's going to be my answer. All right. Let's keep going. Next one. Solve for x, round to the nearest hundredth. So we're going to solve this. So the big deal here is that anytime you're solving the variables in the exponents, that's a key that you want to use logs. So I'm going to just take log 10, 3 to the 3x equals log 98. And we like this because whenever you just write log, it means the base is 10. So this is 3x equals log 98. Also, it's nice when you use log because you can just type it straight in the calculator. So all I got to do is divide by 3 and just type in log 98 divided by 3. And that'll give me roughly 0.66. Okay, cool. And now we're doing 0.66 because it says round to the hundredth. I can't stress this enough. Do the homework, figure out the format in terms of what they're asking for. I will double check, but if it says hundredth and you go to the thousandth, you're going to lose some points. So that's why it's important to do that. Let's see here. I'm actually going to skip that question. Okay, so let's do this one. So it says, what is log 4 to 256? This is log base 4. We want to write 256 as 4 to the what? So I want to stress again, if you don't know what 4 to the what power is 256, that's not a big deal. You just go in the calculator and you go 4 times 4, 16. 16 times 4, 64. 64. You have to do it in this voice too, by the way. 64 times 4, 256. So I did 1, 2, 3, 4 times. So I know this is 4 to the 4th. Once more, really driving this point home. When these match up, it's just the exponent. Boom. Easy enough. Okay. And then the next one What is log 5 to the 25? Okay, so again, I really hope that you know that 25 is 5 squared. These match up, just the exponent. Cool beans. Okay. Next one. This is a nice little dessert at the end of all this work, right? Okay. So we have log 25 raised time. Log base 25, 1 over 25. I really do think every time I have green, there's kryptonite laying around. So more of the same. This one, actually, no, not more of the same. So what I wanted to, I can tell you, let me let you be my therapist. What I wanted to do is I wanted to say 25 raised to a certain power, right? But I don't know what 125 is raised to that power. So what instead, I don't want to do this. I'm just going to say this is equal to x, and I'm going to claw it. Remember that? I'm going to say 25x equals 1 over 125. By the way, when I was writing this here, I said I want to say log base 25. So I wanted to figure out 25 to the what power equals 1 over 125, right? That's what I was saying that I was looking for. And that's exactly what we do when we do the claw, because that's what a log is. Okay. So now we want to clean this up. Whenever I see 5 in the ones place, clearly that makes me think 5 powers of 5. So I'm going to say that 25 is 5. I know that's 5 squared, so that's 5 to the 2x. 125, I hope everybody's cool with. 125 is 5 cubed, but because it's in the denominator, it's going to be negative 3. Okay? So, you know what? Let me just be super clear. So what I'm saying is this, and then, right, 125 is 5 cubed, and then 1 over, right, we said that's just whenever you see the reciprocal of 5 cubed, you just make it negative and you get to match. Okay, so once we do that, if the bases match, then the exponents match. So 2 to the x is negative 3, and x is negative 3 over 2. Cool beans. All right, so the next one is going to be, oops, let's do that again. Okay, let me do this. Apparently Superman struggles with technology. Okay, so log base x to 64 equals 2. If you see this, you're like, that's the noise Superman makes when he doesn't understand. Plot. X squared equals 64. And there's 2 ways of doing this. You could square root it, or you could say, hey, what times what is 64? You're actually doing the same thing. X is 8. So again, if you want a classical way, take the square root. Okay. Awesome. All right. I think one more. Okay, solve for the exact value here. All right, so this is almost like solving for, like, think of all of this as x. You want to get it by itself. So what I'm going to do first here is I'm going to subtract 12. So 6 natural log 5x minus 3 equals negative 12. Then I'm going to just take this, divide through by 6, and we're going to get natural log 5x minus 3 equals negative 2. Now, I'm going to solve this. So one thing that I like to do is if you're looking at this and you're like, man, how do I solve this? Remember, natural log is just log base e. 5x minus 3 equals negative 2. and then we claw it, so we get e to the negative 2 equals 5x minus 3. And then we just solve this. So I'm just going to leave that e as is. I'm going to add 3 to both sides. So e to the negative 2 plus 3 equals 5x. And then just divide by 5. So x equals to e to the negative 2 plus 3 over 5. And that's my answer. So I guess they're asking for a numerical. No, that is actually how they wanted the answer to be. Okay, so never mind. So again, is that what they said? Yeah, I think that's what they said in the question. I didn't copy the question exactly. Okay, so but that's how you solve that. All right. So that is it. I hope this helped you guys out, and y'all are going to be successful with the test. Big thing, got to work through these problems on your own. Make sure you get through all the homework. Good luck, guys. Keep working hard, and you too will become super. All right. Bye-bye.